Okay, so you guys did number 1. You did this. How'd it go? What'd you say? Oh. I feel like most of you did okay. Yeah? Was it just the interval of increase and decrease? Is that the only part? Okay, very common. Again, don't feel bad. You will get the hang of it. It took me a while when I was younger too. When I do interval of increase and decrease, I look right at the axis of symmetry, which is right here in the middle. And then I ask myself, does the left side or the right side increase or decrease? In hand?
Oh yeah. I was gonna use like axis of symmetry.
Good, the axis of symmetry. Okay, that is just the x value of your vertex. So my vertex right here is -1, -4. So my x value is -1. It's the line that if I were to fold it in half would be symmetrical. So if I were to take this corner and this corner and fold it over the line, it should be perfectly symmetrical. If you were a visual person, you can visualize that. If I were to take this and fold it in half, it should be perfectly symmetrical. I can even maybe do an example on here. Okay, I know that mine is not the best drawing right there, but if I were to fold it on my axis of symmetry, it should be perfectly symmetrical on both sides. Obviously mine is not a great drawing, but you see how when I fold it in half, it's perfectly the same on the same side. So that's what it means to be an axis of symmetry. Good question. Anything else you want me to explain? All right, awesome. Okay, today is going to be super easy in my opinion. It's something that we do the whole entire year, probably up until mid-second semester. You get better the more you do it. It's very easy. You'll start to memorize it as you go. It's transformations. You've done this in the past, but we're just going to bring it back for quadratics. It's going to apply the whole semester, which is really nice that nothing changes. So every time that there's a negative out in front, it's going to reflect. So let's kind of talk about what each piece of this means. So we have this is actually called vertex form. This is actually called vertex form, where you can actually find the vertex just looking at your graph or looking at your function. Yesterday I told you guys when I was making the key that I was doing all this in my head. There's a reason. Thank you. I dropped a lot of those yesterday. Because I knew that this was vertex form if that was given, and I can find my vertex just by looking at it. H and K is my vertex, which is really your x and your y coordinate. But when we're talking about transformations, this guy out in front, if it's negative, we're going to concave down. So all those functions that we saw where it looked like a frown upside down, okay, that means that there's a negative out in front. So if it's negative, I'm putting a little negative sign, then it's going to concave down, which is called reflection. Like you're seeing a reflection. Reflect over the x-axis. Only when it's negative. If it's positive, nothing's happening. Okay, so only when it's negative are we reflecting over the x-axis. The reason why I put over the x-axis is because in the future when we do polynomial stuff, we might be reflecting over the y. I just heard it fall. The a out in front means something. So like if you see 2x squared, that 2 means something. If it's greater than 1, you're going to be stretching. So stretch. If it's less than 1, you're going to compress. So what does that mean? I did an example last period. See if I have my hair tied. I don't know where it went. I always lose things that I touch. Yeah, you got to go. Okay. The video will be posted, though, if you want to watch it. I don't know if you're going to be gone the whole period or not. I have no idea.
Should I bring my stuff?
I would just in case. I have no idea what it's for. But the video will be posted, so you can watch it. Oh, here's one. No, it's not. Who's got a hair tie? I know someone's got a hair tie. Yes. Oh, let me see the scrunchie for sure. Okay. So here's your parabola, right? Okay, there's a little U shape. You got to watch this because this is really true. Okay, here's my U. I'm a parabola. I'm a parabola. If I multiply or I stretch you, you get tall and you get skinny. Okay, but if I compress you, actually, you know what? I can't use it with stretching. Oh, there we go. This is nice. Oh, I need to get these ones. That is big. I like that. My hair is so thick. Okay, this one's a lot better just because it's a lot easier to see visually. Here's my U shape. If I stretch you, look at that. You got tall and you got skinny. Okay, however, if I shrink you, if I compress you, it's like a compression from like a garbage disposal kind of thing. if I compress you, you're going to get wider. So if you're a girl, I mean, maybe a boy too, but I always say, like, man, I wish I was really tall because I'd be, like, really skinny. Okay, that's what I would always think when I was younger. Like, all those models that are, like, really tiny because they're, like, 6 feet tall. Or even guys, same thing. When you're 6 feet tall, you're usually a little bit smaller. Okay, so that's what it is. If I were to take you and I were to stretch you, you would get a lot skinnier. And if I were to, like, and shrink you, you would definitely get a lot wider. That's what compressing is. So that's what it means. If it's bigger than 1, if I multiply you by 2, you're going to stretch. And if I compress you, if I cut you in half, you're going to go ahead and you're going to compress. Now I lost my pen. Who's got me? There it is. Got it. Okay. Now, in this function, the h value, if it's positive, you're going to move left. If it's negative, you're going to move right. So whenever you have parentheses, you move left or right. Now, if there were no parentheses at all, like 2x squared plus 1, you wouldn't be moving left or right. And then the last guy, this k value, if it's positive, you're going to move up. If it's negative, you're going to move down.
I can't read the first part. The first, like, smidge. Is that supposed to be an arrow?
Oh, it's an arrow, my bad.
Sorry.
Just telling you that the k means if you move up and down. Okay? You're just checking to make sure you write that nice and neatly because you will be using this a lot. We're going to spend a lot of time on transformations the next couple days because it's super important that you master it now because it's only going to benefit you when we do chapter 5 and 6 and 8 and 9. Okay, all those chapters you will be doing transformations. And they're all the same, which is great. So you don't have to like change anything. It's all going to be the same. Okay, let's talk about a problem. Actually, let me get rid of this. Don't look at my answers. Okay, so it's going to ask you for the transformations. It's going to ask you for the vertex because we're in vertex form, and it's going to ask you to sketch the function. So let's start with the transformations. You start off with x squared, and I need to find out what is transformed. What are you doing up here? Get skedaddle. Okay, this negative means something. The 1/2 means something. The 3 means something. And the 4 means something. I have 4 transformations. 4. And if you look what's left, x squared. It asks you what's the transformation on x squared. And that's what's left after I just highlighted and talked about those. So what's great about this is you can actually tell how many transformations are going to happen by just looking at it. 1, 2, 3, and 4. 4 transformations you need to write down. So what does a negative do out in front? Does anyone kind of remember or what'd you say? If I was inside the parentheses, maybe. But I'm all the way out in front. And I'm a negative. Huh? It's going to be reflecting down. Okay, reflecting down. Remember how we had graphs that looked like they were up and they looked like they were down. This means that we're going to reflect. Now, like, draw an arrow so you know that's where it's coming from. Reflect over the x-axis. And I write that out because, again, there will be times where we reflect over the y. Okay, this 1/2, now think about the rubber band. Would I be getting tall and skinny? Would I be stretching or would I be compressing if you're cut in half or squished in half? Very good, you'd be compressing. So I'm just going to keep drawing arrows, and I know it kind of gets a little messy, but it's just for the sake of this note right here. This arrow means I'm going to be compressing by 1/2. And just trying to show you in your notes, if you go back and look at your notes, you at least know where it's coming from. Okay. What about this 3? It's inside the parentheses. Look back at your notes above. If it's a negative, are you moving left or right? Be careful. Yeah, you're moving right. Very good. Right. 3. And this one's the easiest one. What does a 4 outside the parentheses mean I'm doing to my graph? Yeah, up 4. So look at that. We have 4. 1, 2, 3, and 4. 4 transformations. I promise you in time, you will get better and it'll be really fast. You're going to be like geniuses at the end of the year with these. Okay, so with that said, you can find your vertex. In vertex form, it's just HK. Now, remember, HK is just right here, 3, 4. That's your vertex. Your vertex right here, HK, is 3, 4. Or, you can think of it this way. And this is how I was showing them last period too, and they liked it like this. When we go to sketch your graph, it's going to tell you what your vertex is. If I move right 3, let's label it, right 1, 2, 3, and I go up 4, 1, 2, 3, 4, you just found your vertex. That was it. Wow, that does not look like it's right there, but here. 3, 4. So either way, either knowing the formula that it comes right from here, or knowing that you went right 3 and up 4, that's going to be your vertex. Now, the one thing I would like to know, do you think we're concave up or concave down?
Up.
Why down? You're right. I don't know who said it. It's down because you have a negative all the way out in front next to the equal sign. So we're just going to sketch it. You don't have to get out your calculator and actually get some points. I just want you to sketch. So all I care about is that you put your vertex there based off of our transformations, right? 3 up 4, or knowing the formula. And then concave down because I have a negative out in front. Now the first one was probably like, oh my god, that's ridiculously hard. It gets easier, I promise, once you get used to it. We did this the past couple days. Is this going to have a max or min now that we just drew that out? A max. Yeah, because look, if I highlight this in green, there is nothing higher or more than that vertex point. There's stuff lower than it, just not higher. So what is that value that you can't go past? What's the highest point? In green. What's the highest it goes?
4.
How much? 4. Very good. It goes 4. And that's coming from right there.
At x equals 3.
At x equals 3. And look at that. That came right from our vertex. And we did that yesterday. Okay, that was the first one. We ripped the Band-Aid off. That was a hard one, and now it'll start being easier. Go ahead and flip when you're ready. We only got a couple more, and then you'll have like 20 minutes for your homework. For 4 questions. Your faces are adorable. Okay, moving on. Oh, don't look at mine. Don't look at mine. I forgot to erase it from last week. Delete. Okay. And we're back. Okay, number 2. Let's talk about it. Can someone at least tell me how many transformations I'm going to have? Go ahead.
Around 3 or 4.
Around 3 or 4? Can you be more specific on which one you think it is?
3.
3. I'm going to go with 4, and here's why. But that was great that you're around 3 or 4. Because look, there's 1, there's 2, there's 3, and there is 4. Okay, so that negative is different than the 3. The negative means I'm reflecting. The 3 means I'm doing something else too. So I'm going to color code it in blue. What does the negative mean I'm doing? Try to remember. You look in the mirror and you see your reflection. Reflect over the x-axis. Okay. Now try to think of what the 3 means. The 3 on front means I'm multiplying by 3, which means I'm like multiplying you by 3. So is that stretching or compressing?
Stretch.
Very good. Stretch. Good. Remember, you're getting tall and skinny. You want to multiply by 3. I mean, I want to multiply by 3. That'd be awesome. I'd be like super tall. This is probably the hardest one of the bunch, the one in purple, because it's originally a negative and it changed to positive. So, am I going to be moving left or right in this situation? I can't hear. I'm sorry. I'm deaf.
Right.
I heard right. Right would be correct if it wasn't originally negative. So it's going to be moving left 2.
Wait, would it also be left as read stretch?
So stretch doesn't really, it doesn't go, yeah, it doesn't matter if it's stretching or compressing. Yeah. Everything is separate. Treat every piece separate. And here's what I was telling last period too. You kind of just like go in order. If it's negative, it's reflecting. So it's either reflecting or it's not. You have a 50-50 shot. Here, it's either stretching or compressing, and that's it. Or nothing. It could be doing nothing either. Here, left or right. Here, up, down. You have like a 50-50 shot on each one of them. All right, this yellow one. What do you think? This one's the easiest one, I think. It's all the way at the end. It's either up or down.
Negative.
Down, so that's negative. Very good. Down 1. So let's sketch that out. All I care about is going left 2, 1, 2, and down 1. And go ahead and put a point there. That's your vertex. So if I went left 2, do I have a positive or a negative 2? A very good, a negative 2. And that's what I mean by it's originally negative and it changed the positive because of that. And going down 1, it would be negative 1. And that's your HK. You could have looked at your vertex formula and look, there's HK. It tells you that. It tells you it's negative 2, negative 1. Okay. Am I going to be concave up or concave down? Is it? I'm hearing lots of 50. Yeah. Okay, I heard it back there. It's down because this right here. If there is a negative all the way out inside in front of, all the way out by the equal sign, it's going down. Would you say, Riley? I couldn't hear you.
I said down first.
Oh, okay. Yeah. I'm like going deaf. I think I'm getting old. Okay, do I have a max or a min here?
And then max.
A max, because there is no value that is bigger than this one in green. And in green, what is the highest value of this graph?
Negative 2.
Thank you, negative 1. Right here, negative 1. That's the highest value, but it's located where? Riley? You had said it before. Negative 2. And here's a hint to you. Look, it actually says x equals. And x equals is that x value of the vertex. You're going to get better. Okay, I want you to do this one for your homework. Not for your homework. To get your home. Actually, no, we have another round. One more. Sorry. I didn't know that there was 2 more here. I'm actually going to change number 3 for a reason because people were asking me this question on the homework. I'm going to cross this off. So can you like scribble this guy out? And that's because on the homework people were having questions if that didn't exist there. So let's pretend that that 2 is no longer there. So we look at our function. Can someone just tell me, are we concave up or down? Up, because there's no negative. So that's great. We don't even have to write anything about reflection. Awesome. What does this 1/2 do? Stretch or compress? Compress, very good. Now, this 4, people always get tricked up on this one, but it's okay. It's originally negative, so we're good. So am I moving left or right here?
Right.
Very good, right. 4. And look, there is nothing that I crossed it out. Now there's nothing here. So we're not moving up or down anything. And that's okay, and that happens. We actually did questions like this yesterday where the vertex was just on the y-axis. So let's actually graph that out. I went right 1, 2, 3, 4, and I went up nothing. So that's where my vertex is, right there. I went right 4 and I didn't move at all. And I was told earlier that I go up, and that was correct. Go ahead and finish this problem, and I will give you your homework, and you should be able to finish before you leave. Like, if you don't, I would be really upset.